Hello everyone, this is Dr. K. Jagannayaki, Professor in MBA Department, Institute of Aeronautical Engineering, Hyderabad. So today I would like to discuss with you about problem solving and capital budgeting techniques. After going through this topic, the learner will be able to understand the concept of critical thinking and problem solving in real life situations and how capital budgeting problems can be resolved. So let us start with the problems. The cost of a project is 50,000 and annual cash inflows for the next 5 years are given as follows. First year 25,000, second year 25,000, third year 25,000, fourth year 25,000, fifth year 25,000. So if you add all the 5 years, the total is 1,25,000. Using this data, determine the payback period for the project. So in case of payback period, we used to discuss about two types of situations. The first one is even cash flows, second one is uneven. So in case of even cash flows, which means that if the company is going to generate the same annual cash inflows, the same amount of cash inflows throughout the lifespan of the project, that type of cash flows are known as even cash flows. So in this case, the payback period can be computed by using the formula payback period is equal to initial investment divided by annual cash inflows. So the initial investment is nothing but the cost of project which is given as 50,000 and divided by annual cash inflows 25,000. Then payback period is equal to 2 years. It means that the company can recover its initial investment of 50,000 within 2 years. The following details are related to three mutually exclusive projects. Find payback period for all the three projects. Standard payback period is 3 years. Suggest the management which project should be acceptable. The initial cash outlay of project is 1 lakh rupees, which is common to all the three. So this is the data which is furnished, particulars, cash inflows of project A, project B's cash inflows and project A's. Now, for the comparative analysis, so I have projected all the three in one slide, project A, project B and project C. So coming to project A, the company is going to generate equal cash inflows throughout the lifespan of the project. So as a result, I have used the formula payback period is equal to initial investment divided by annual cash inflows. The initial investment, which is also known as the cost of capital, that is 1 lakh divided by 30,000. So payback period is 3.33. Coming to project B, if you observe this particular project, first year 30,000, second year 50, third year 40, fourth year 20, fifth year 10. So there is no uniformity among the cash inflows. So as a result, here I am going to use other formula. Payback period is equal to E plus B by C. See, if you want to find out payback period under uneven cash flows, we should consider cumulative cash flows. So first year 30, 30 plus 50, 80,000, 80 plus 40, 1 lakh 20, 1 lakh 20 plus 20, 1 lakh 40 plus 10, 1 lakh 50. Then apply the formula payback period is equal to E plus B by C. E means what is the maximum amount that the company can generate in which year. So if you observe at the end of second year, 30 plus 80, 1 lakh 10,000. So the company can generate maximum amount 80,000 at the end of second year plus the leftover balance 1 lakh minus 80, 20,000 it is going to recover in later years. So that should be recovered. The amount left over, B means balance amount 20,000 divided by that 20,000 it may recover in the third year, right? So whatever the cash flows that should be considered. So 2 plus 20,000 divided by 40,000. So the payback period is 2.5 years. And coming to third project, that is project C, here also uneven cash flows. So find out the cumulative cash inflows, compare and apply the formula PBP is equal to E plus B by C. See, if you see in this problem, by third year the company can recover its initial investment. 3 plus leftover balance is 0 by 20,000. So your payback period is 3 years. So since the standard payback period is 3 years, it is always better to go with the project that is less than standard payback. See, if you observe project B, payback period is 2.5 years, which is less than the standard payback. So among all the three project B should be accepted. Next, a project requires an investment of 6 lakhs rupees and has a scrap value of 30,000 after 4 years. So it is expected to yield profits after depreciation and taxes during the 4 years amounting to 40,000, 60,000, 50,000, 30,000 rupees. Calculate accounting rate of return or average rate of return on their investment. So ARR is computed by the formula average net profits by average investment. So average net profits can be derived by taking the total of all the net profits divided by number of years. So average net profit is 45,000 and whereas average investment net investment by 2. So how can we find out the net investment? Investment minus scrap value. So here the investment of the project is 6 lakhs minus 30,000, that is scrap value. So 5 lakh 70,000 by 2. So average investment becomes 2 lakhs 85,000. Then substitute these values in this formula. We'll get accounting rate of return or average rate of return on this particular project is 15.78%. Then a project proposed requires cash outlay of 19,000 rupees and is expected to generate cash inflows of 8,000, 6,000, 4,000, 2,000 and 4,000 over next 5 years. Calculate payback period for given projects. So this is the case of uneven cash flows. So as a result, we should convert cash inflows into cumulative cash inflows. Then apply the formula payback period is equal to E plus B by C. So if you see that at the end of third year, the company can recover 18,000 out of 90,000. So 3 plus the leftover balance is 1 lakh 1,000 and divided by that should be recovered in the fourth year. So the cash inflow of fourth year is 2 lakh 2,000. So 3 plus 0.5, the payback period for this particular project is 3.5 years. So the company can recover its initial investment of 19,000 within 3.5 years. The next, calculate the internal rate of return of an investment rupees 1,36,000, which yields the following cash inflows. First year 30,000, second year 40, third year 60, fourth year 30,000, and fifth year 20,000. And rate of return is 10%. So just by using this data, first of all calculate NPV by taking the given rate of return as 10%. So cash inflows has given and find out PV factors by using the formula PV factor is equal to 1 by 1 plus R whole to the power of n. Substitute R is equal to 10 and n is equal to 1, 2, 3. So using this formula I have generated cash inflows for PV factors for all the 5 years. Then find out present value of cash inflows just simply multiplying 30,000 with PV factors will get that. Then find out sum of PV of cash inflows 1,38,190. Then substitute in the formula, NPV is equal to sum of present value of cash inflows minus sum of present value of cash outflow. So here we got a positive NPV. Then this method is based on trial and error. We should keep in mind that we need two rates. One rate is higher to PV factor and other rate is lower to PV factor. And then we need to calculate NPVs at those rates. So NPV at one rate should be negative and NPV at one rate should be positive. So we should also keep in mind lower the rate, higher the NPV, higher the rate, lower the NPV. So in this problem, a 10% rate of return, the NPV is positive. So let us try for a higher rate. So I have assumed R is equal to 12%, again calculated NPV. So if R is equal to 12%, then I have generated the PV factors using the same formula. PV factor is equal to 1 by 1 plus R whole to the power of n. Then multiply cash inflows with PV factors and find out present value of cash inflows. Then sum of this present value of cash inflows is 1,31,810. Then substitute in this formula, NPV is equal to sum of present value of cash inflows minus sum of present value of cash outflow. Then here we got negative NPV. Then apply the formula to compute IRR. Internal rate of return is equal to lower rate plus NPV at lower rate divided by NPV at lower rate minus NPV at higher rate into higher rate minus lower rate. So in this case, lower rate I have taken as 10% and higher rate assumed 12%. NPV at 10% is positive and NPV at 12% we got negative NPV. So substitute these values in this formula and we got NPV IRR value is 10%. So IRR is that rate of return where the NPV equal to 0. So it means that the present value of cash inflows equal to present value of cash outflows. The next, calculate NPV for the given project. The company anticipates the cost of capital of 12%. Rank the project according to it. So as we have given two projects A and B. So project A NPV is 18.135. Just have multiplied cash inflows with PV factors at the rate of 12% and identified the present value of cash inflows and substitute in the formula NPV is equal to sum of PV of cash inflows minus present value of cash outflows. And whereas coming to project B, the cash inflows may vary for project B and the same PV factor at 12% I have generated present value factors and then multiplied cash inflows with PV factors and substituted in the formula NPV is equal to summation PV of cash inflows minus PV of cash outflow. So here I got a negative NPV. So ranking. So in general, if the company should go with project A, why? Because we have a positive NPV. If NPV is positive, accept the project. If it is negative, reject the project. So calculate IRR if the project requires an initial outlay of 6,000 and expected to generate equal cash inflows of 2,000 per annum. The project is having a life of 5 years. Advise the management if the cost of capital is 15%. So here we should go with PV factor by using the formula initial investment by annual cash inflows. So here the present value factor is 3%. The value nearest to PV factor value 3 from present value annuity factor table, that is 2.9906, which we got at 20%. So consider the highest value at the rate of 20. Again calculate PV values and substitute these values in this formula. IRR lower rate plus NPV at lower rate divided by NPV at lower rate minus NPV at higher rate into higher rate minus lower rate. Then our internal rate of return is 15.048. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.